Mallika, Department of Mathematics and Statistics. Today my topic is rank correlation. Rank correlation was introduced by Spearman. Let us suppose that x1, x2 and so on xn and y1, y2 and so on yn be the ranks of n individuals of the two characteristics A and B. x1, x2 and so on xn and y1, y2 and so on yn be the ranks of n individuals of the two characteristics A and B. The correlation obtained for the ranks of n individuals of the two characteristics A and B is called rank correlation coefficient. In this rank correlation coefficient, the ranks of the two characteristics A and B may or may not be same. May and may not be same. Then derivation of rank correlation coefficient. Derivation of rank correlation coefficient. In this derivation, we assume that ranks of the two characteristics are not same. That is, xi not equal to yi. Xi not equal to yi. Then let us consider x bar. We know x bar is equal to 1 by small n summation xi over I is equal to 1 to n, which is equal to 1 by small n into, instead of xi we will consider ranks 1 plus 2 plus and so on plus n, which is equal to sum of n terms n into n plus 1 by 2. That implies x bar is equal to n into n plus 1 by 2. Already here 1 by n is there. N get cancelled. You get x bar is equal to n plus 1 by 2. Similarly, y bar also n plus 1 by 2. Then let us consider sigma x square. We know sigma x square is equal to 1 by small n summation xi square minus x bar square. Here over I is equal to 1 to n, which is equal to 1 by n. Summation xi square means 1 square plus 2 square plus and so on plus n square minus. Already we know x bar value is n plus 1 by 2. Substitute this value n plus 1 by 2 whole square. Sum of squares of n terms. This will becomes 1 by n into n plus 1 into 2n plus 1 by 6 minus n plus 1 by 2 whole square, which is equal to n get cancelled. Take n plus 1 by 2 is common. Then you will get 2n plus 1 by 3 minus n plus 1 by 2 minus of n plus 1 by 2, which is equal to n plus 1 by 2. Take LCM. LCM is 6. You will get 3 2s, 2 2s, 4s, 4n plus 2 minus 3n minus 3, which is equal to n plus 1 by 2. Here you will get n minus 1 by 6. n plus 1 into n minus 1. A plus b into a minus b. That is nothing but a square minus b square. Like that you will get n square minus 1 by 12. This is sigma x square. Similarly, sigma y square becomes n square minus 1 by 12 only. Therefore, x bar is equal to y bar. X bar value is n plus 1 by 2. Y bar is also n plus 1 by 2. So, x bar is equal to y bar. Called it as equation 1. Next, from this sigma x square is equal to sigma y square, call it as equation 2. So x bar value is equal to y bar value is equal to n plus 1 by 2. Sigma x square is equal to sigma y square is equal to n square minus 1 by 12. Then assume that Rho is rank correlation coefficient and is given by rho is equal to covariance of xy by sigma x sigma y. From this equation I want covariance of xy. Covariance of xy becomes rho sigma x sigma y. Let us assume that deviation of the ranks is di and is given by di is equal to xi minus yi. Let us assume that di is the deviations of the ranks, that is di is equal to xi minus yi. Add and subtract x bar. From this you will get di is equal to xi minus x bar plus x bar minus yi. From this we will write xi minus x bar, take minus is common, you get yi minus xi minus x bar, yi minus x bar. Then you will get, take summation. Yes, take squaring on both sides, you will get di square is equal to xi minus x bar minus yi minus x bar, then whole square, which is equal to di square is equal to a minus b whole square. This is a square plus b square minus 2ab. This can be written as xi minus x bar minus yi minus, instead of x bar we write x bar is equal to y bar, yi minus y bar whole square, which is equal to di square is equal to a minus b whole square, a square xi minus x bar whole square minus a minus b whole square, a square plus b square minus 2ab, yi minus y bar whole square minus 2 into xi minus x bar into yi minus y bar. From this equation take summation and divide by n on both sides. Take summation and divide by n on both sides. You will get summation di square by n is equal to summation xi minus x bar whole square by n plus summation yi minus y bar whole square by n minus 2 times summation xi minus x bar into yi minus y bar by n. We know that summation xi minus x bar whole square by n is nothing but sigma x square plus this is sigma y square minus 2 times summation xi minus x bar into yi minus y bar by n is nothing but covariance of xy, covariance of xy. That implies summation di square by n is equal to sigma x square plus sigma y square minus 2 times. We know covariance of xy is equal to rho sigma x sigma y. Covariance of xy is equal to rho sigma x sigma y, which is equal to sigma x square plus sigma, instead of sigma y square I will write sigma x square is equal to sigma y square. So instead of sigma y square we will consider sigma x square minus 2 times rho sigma x, sigma y is nothing but sigma x, which is equal to 2 times sigma x square minus 2 times rho sigma x into sigma x square. Take sigma x square is common, you will get 1 minus 1 minus rho. This is summation di square by n is equal to 2 sigma x square into 1 minus rho. From this equation, I want 1 minus rho. 1 minus rho is equal to summation di square by 2n sigma x square. 2n sigma x square. From this equation, that implies I want rho. Rho is equal to 1 minus summation di square by 2n sigma x square, which is equal to 1 minus summation di square by 2n. What is sigma x square? N square minus 1 by 12. N square minus 1 by 12. 2 ones 2 6, which is equal to 1 minus summation di square by n into n square minus 1 by 6. From that equation, we will get rho is equal to 1 minus 6 times summation di square by n into n square minus 1. This is the derivation of rank correlation coefficient. Rank correlation coefficient is denoted by rho and is given by rho is equal to 1 minus 6 times summation di square by n into n square minus 1. Limits of rank correlation coefficient. We know that rho is equal to 1 minus 6 times summation di square by n into n square minus 1. We know that rho is equal to 1 minus 6 times summation di square by n into n square minus 1. In this limits of rank correlation coefficient, we have two cases. Case 1, when rho is maximum. When rho is maximum, if summation di square over I is equal to 1 to n is minimum. When summation di square is minimum, that is summation di square is equal to 0 over I is equal to 1. When summation di square becomes 0, if the ranks of the two individuals are same, if the ranks of two individuals are same, then summation di square becomes 0. If summation di square is 0, then we'll get rho is equal to 1 minus, substitute in this place 0, then you'll get 1 minus 0, that implies rho is equal to 1. Call it as equation 1. So in case 1, rho is maximum if summation di square is minimum. Summation di square is minimum means summation di square value is 0. When summation di square value 0, if the ranks of the two individuals are same, if the ranks of the two individuals are same, then case 2. In case 2, rho is minimum if summation di square is maximum. Summation di square is maximum. When summation di square is maximum, if the ranks of the two individuals are in opposite direction. If the ranks of two individuals are in opposite direction, that is xi is the ranks of the character A. The ranks are like this 1, 2, 3 and so on, n minus 1, n. Y is ranks of the character B, opposite direction. So here you will get n minus 1, n minus 2, n minus 3 and so on to 1. See, observe the ranks of xi and the ranks of yi, they are in opposite direction. Then only rho is minimum. When rho is minimum, that is if summation di square is maximum. When summation di square is maximum, if the ranks of the two individuals are in opposite direction. From this table, I want xi plus yi. From this table, I want xi plus yi. That is n plus 1. Total becomes n plus 1. Already we know that di is equal to xi minus yi. Di is deviation of the ranks. Xi minus yi is equal to di. Solve these two equations, we'll get times xi is equal to n plus 1 plus di. N plus 1 plus di. From this equation I want di. Di becomes 2 times xi minus of n plus 1. I want di. Di is equal to 2 times xi minus n plus 1. Squaring on both sides and taking the summation. So I will get summation di square is equal to summation of 2xi minus of n plus 1 whole square. Taking summation and squaring on both sides. That implies summation di square is equal to, this is in the form of a minus b whole square. That is summation of a square 2xi square 2xi whole square minus of n plus 1 whole plus n plus 1 whole square minus 2ab 2 into 2xi into n plus 1. That implies summation di square is equal to, split the summation, here 2 square becomes 4, 4 is constant, take outside, summation I is equal to 1 to n xi square plus summation I is equal to 1 to n plus 1 whole square minus 2 to 4, n plus 1 is also constant, take outside, 4 times n plus 1 summation xi over I is equal to 1 to n. No need of this brackets, which is equal to 4 times sum of square terms. Sum of square terms is n into n plus 1 into 2n plus 1 by 6 plus, this is constant, total summation becomes n. So for this we will get n into n plus 1 whole square minus 4 times n plus 1 summation xi, sum of n terms, this is nothing but n into n plus 1 by 2, n into n plus 1 by 2. Again from that equation, two twos, two threes. What is the common term in all? N into n plus 1. Here also n into n plus 1 is there. Here also n into n plus 1 is there. Take n into n plus 1. Take n into n plus 1 is common. You will get 2 times 2n plus 1 plus n plus 1 minus, here also 2 ones, 2 twos, then you will get 2 times n plus 1, 2 times n plus 1. From this equation, here we have by 3, again take n into n plus 1 by 3 common, you will get by 3 so then you will get here plus 3 times, then here you will get minus 6 times, right? Next n into n plus 1 by 3, multiply these two, you will get 4n plus 2 plus 3n plus 3 minus 6n minus 6. Then you will get n into n plus 1 by 3, 4n plus 3n, 7n minus 6n. You will get n plus 2 plus 3 plus 5 minus 6, you will get minus 1. Simply you will get n minus 1. n plus 1 into n minus 1, a plus b into a minus b, that is a square minus b square. Similarly you get n into n square minus 1 by 3, n into n square minus 1 by 3. This is summation di square. Substitute the summation di square value in row. We know already rho is equal to 1 minus 6 times. Instead of summation di square, substitute this one, n into n square minus 1 by 3 by 1 minus 6 times summation di square by n into n square minus 1, n into n square minus 1. From this equation you will get 1 minus this n into n square minus 1, this n into n square minus 1 get cancelled, 3 ones, 3 twos, 1 minus 2, you will get minus 1, call it as equation 2. From equation 1, that is in case 1, row becomes 1. In case 2, row becomes minus 1. That means row value is plus or minus 1. Row value is equal to plus or minus 1. In equation 1, we will get row is equal to plus 1 in case 1. In case 2, we will get row is equal to minus 1. That means row value is plus or minus 1. That implies minus 1 less than or equal to row less than or equal to plus 1. The limits of rank correlation coefficient is minus 1 to plus 1.